Let us consider nth order non-homogeneous linear differential equation with constant coefficients. In symbolic form, it is f of d into y equals sign capital letter f of x. Then the particular integral is equal to 1 by f of d numerator capital letter f of x. Again this is equal to 1 by h of d square numerator f of capital letter f of x where f of d is equal to h of d square. Suppose capital letter f of x is equal to e to the power ax, where a is a constant. I already explained the method to find out the particular integral. Now, let us assume capital letter f of x is equal to sin ax or cos ax, where a is a constant. Now let us see the method to find out the particular integral when capital f of x is sin ax or cos ax. Write the step pi equal to 1 by h of d square numerator sin ax or cos ax. Substitute d square is equal to minus a square with the condition that h of minus a square is not equal to 0. h of minus a square is not equal to 0 means that denominator is not equal to 0 when putting d square is equal to minus a square. Suppose denominator is 0 when d square is equal to minus a square. We must write the equivalent formula, that is pi is equal to 1 by h dash of d square, left hand side of this x, right hand side of this sin ax or cos ax. Here h dash means differentiation. So in this formula, put d square is equal to minus a square if h dash of minus a square is not equal to 0. H dash of minus a square not equal to 0 means that denominator is not equal to 0 when putting d square is equal to minus a square. Suppose denominator is 0 when d square is equal to minus a square, we must write the another equivalent formula, that is pi is equal to 1 divided by h double dash of d square, left hand side numerator write x square, right hand side numerator sin ax or cos ax. Here h double dash of d square means that h of d square must be continuously differentiated 2 times with respect, continuously differentiating 2 times. Now in this formula, put d square is equal to minus a square with the condition that h double dash of minus a square is not equal to 0. H double dash of minus a square not equal to 0 means that denominator should not be equal to 0 when putting d square is equal to minus a square. Suppose the denominator h double dash of d square is equal to 0 when d square is equal to minus a square, we must write another equivalent formula, that is Pi is equal to 1 divided by h triple dash of d square, left hand side of this x cube, right side sin ax or cos ax. In this we must substitute d square is equal to minus a square with the condition that the denominator is not equal to 0. Suppose denominator is equal to 0 when d square is equal to minus a square, the extension of this formula must be used. So this is the method to find out the particular integral when capital letter f of x is equal to sin ax or cos ax. What is this capital letter f of x means? The function given in the right hand side. So I repeat, to find the particular integral, first you write pi equal to 1 by h d square, h of d square, right side of 1 by h of d square sin ax or cos ax. So in this one, you put d square is equal to minus a square such that the denominator is not equal to 0. Suppose denominator is equal to 0 when d square is equal to minus a square, write the another equivalent formula for pi equal to x into 1 by h dash of d square, numerator sin ax or cos ax. So remember, x must be written left hand side of 1 by h dash of d square, that sin ax or cos ax must be written right side of 1 by h dash of d square. So in this equivalent formula, put d square is equal to minus a square with the condition that the denominator is not equal to 0. Suppose denominator is equal to 0 when d square is equal to minus a square, write the another equivalent formula pi equal to 1 over h double dash of d square, left side x square, right side of 1 by h double dash of d square, right sin ax or cos ax. So in this equivalent formula, put d square is equal to minus a square such that the denominator is not equal to 0. Suppose denominator is equal to 0 when d square is equal to minus a square, write the next equivalent formula for the particular integral, equal sign x cube into 1 by h triple dash of d square sin ax or cos ax. So in this equivalent formula, put d square is equal to minus a square with the condition that denominator is not equal to 0. So like this, the rule can be extended. Pi equal to, take the left hand side d square minus 8d plus 9 to the other side, that becomes 1 over d square minus 8d plus 9. Right hand side we have 8 into sin 5x, that the constant 8 can be written left hand side of the operator, and sin 5x, the function must be written right side of the operator, 1 divided by d square minus 8d plus 9. Now you see the second rule given in the procedure of particular integral. Okay, the right hand side function is sin ax or cos ax. Put d square is equal to minus a square. Remember here this is not equal to minus a the whole square. This is d square equal to minus, the square is only for a. Okay, so now what we have is sine 5x. So we put d square is equal to minus 5 square, that is minus 25. Okay, so substitute this for d square. Do not substitute anything for d. Write the term having d as it is. So what happened? 1 by minus 25 minus 8d plus 9 and numerator sine 5x. See, remember, you have to write only for d square. D term must be as it is. Do not substitute anything. Okay, is it clear? That now this is 8 into 1 by minus 8d minus 16, a numerator sine 5x. If there is any common factor, you take it out. Denominator minus 8 is a common factor. I took it out. Then remaining is minus 1 by d plus 2 into sine 5x. See here, in case of sin ax or cos ax, our substitution is only for d square, not for d. But here we have d. Now to make d square, multiply and divide by d minus 2. Why? Because we have d plus 2. D plus 2, two terms. Change the sign in any one term. It is your choice. In two terms are there. Change sign in one place. Here I change the sign for plus 2. So multiply and divide by d minus 2. Because of this, you can make d square in the denominator. So after multiplying by d minus 2 and divided by d minus 2, the denominator you must adopt a plus b into a minus b formula. What is that? A square minus b square. Now we get minus d minus 2 inside the bracket numerator sine 5x. Denominator, after using the formula a square minus b square, we get d square minus 4. Now substitute d square is equal to minus 5 square, that is minus 25 in the denominator, not in the numerator. So if the denominator when putting d square is equal to minus 25, denominator is not equal to 0. So what happened? The value is minus 29. Numerator expand. So ಏನಾಯ್ತು d into sin 5x minus 2 into sin 5x. See, d for differentiation. D means d by dx. So here d sin 5x means differentiate sin 5x. So we get cos 5x into 5. Therefore the particular integral is 1 by 29 into 5 cos 5x minus 2 sin 5x. Finally, we write general solution is y is equal to CF plus PI. CF is C1 e to the power 4 plus root 7 inside the bracket, outside the bracket x, plus C2 into e to the power 4 minus root 7 into x, plus particular integral 1 by 29 5 cos 5x minus 2 sin 5x. So the problem is complete. Next problem, solve d square plus d plus 1 into y equal to sin 2x. Auxiliary equation d square plus d plus 1 equal to 0. So it's a quadratic equation. It has two values for d. Using the formula, d is equal to minus 1 plus or minus square root of 1 minus 4 whole divided by 2, which is minus 1 plus or minus I root 3 whole divided by 2. So now the two values of D are complex numbers, respectively minus 1 by 2 plus I root 3 by 2, minus 1 by 2 minus I root 3 by 2. Okay. So here they are complex numbers. Now you see the case 3 in the procedure. It says CF is equal to e to the power real part. What is that? Minus 1 by 2. So e to the power minus 1 by 2 x bracket starts C1 cos root 3 by 2 x. Remember, root 3 by 2 is imaginary part. Plus C2 into sine root 3 by 2 x. Next, we find the particular integral. So take the left hand side d square plus d plus 1 to the right hand side. So what happened? 1 by d square plus d plus 1 numerator sine 2x. Sine 2x is given in the right hand side of the equation. So put here d square is equal to minus 2 square. It is minus 4. Okay. Then we get 1 divided by minus 4 plus d plus 1 sine. So 1 by d minus 3 sine 2x. See, in case of the right hand side function is sine ax or cos ax, we need d square term in the denominator. But here we have d, we don't have d square. So to make d square, multiply and divide by d plus 3. How I got this d plus 3? By changing sign in any one of the two terms, not both. We have d minus 3. So change the sign in any one place. Here I change the sign minus 3 to plus 3. So multiply and divide by d plus 3. Then the next step you must adapt a plus b into a minus b formula, that is a square minus b square. Now the numerator is d plus 3 inside the bracket sine 2x. Denominator using the formula of a square minus b square, we get d square minus 9. Now put in the denominator d square is equal to minus 2 square, that is minus 4. So that denominator is not equal to 0. I am getting a number minus 13. Numerator expand. So first term is d sine 2x. Second term is 3 sine 2x. First term d sine 2x. As I told already, d for differentiation. So differentiate it, we get cos 2x into 2. Therefore, the particular integral is minus 1 by 13 inside the bracket 2 cos 2x plus 3 sine 2x. Finally, we write the general solution is y is equal to CF plus PI. CF is e to the power minus x by 2 inside the bracket C1 cos root 3 by 2x plus C2 sine root 3x by 2. Particular integral minus 1 by 13 inside the bracket 2 cos 2x plus 3 sine 2x. So the proof is complete.